The backpropagation algorithm, developed by Paul Werbos in 1974, is a fundamental technique in the field of artificial neural networks. It revolutionized the field by enabling the training of deep neural networks and laid the foundation for many modern machine learning techniques. Backpropagation is a supervised learning algorithm that aims to train a neural network to learn and generalize from input-output pairs of data. The algorithm uses a gradient-based approach to adjust the weights of the neural network in order to minimize the difference between the predicted outputs and the desired outputs. The algorithm consists of two main phases, the forward pass and the backward pass. During the forward pass, the input data is propagated through the neural network layer by layer, starting from the input layer and moving towards the output layer. Each neuron in the network performs a weighted sum of its inputs, passes the result through an activation function, and passes the output to the next layer. This process continues until the output layer produces a prediction. In the backward pass, the error between the predicted outputs and the desired outputs is calculated. This error is then propagated backward through the network, from the output layer to the input layer, in order to update the weights and biases. The goal is to minimize the error by adjusting the weights in a way that reduces the difference between the predicted outputs and the desired outputs. To update the weights, the algorithm uses the chain rule of calculus to compute the gradient of the error with respect to each weight. The gradient indicates the direction and magnitude of the weight adjustment required to reduce the error. The backpropagation algorithm calculates these gradients layer by layer, starting from the output layer and moving backward. At each layer, the algorithm computes the local gradient of the error with respect to the inputs of the neurons in that layer. This gradient is then used to determine the contribution of each weight to the overall error. The weights are updated by subtracting a fraction of the gradient from their current values, which is controlled by a learning rate parameter. The backpropagation algorithm continues to iterate through the forward and backward pass steps, adjusting the weights after each pass, until the error reaches an acceptable level or a maximum number of iterations is reached. This iterative process allows the neural network to learn and refine its weights, gradually improving its ability to generalize and make accurate predictions. It's worth noting that the backpropagation algorithm requires the use of differentiable activation functions, as the gradients are computed based on these functions. Popular choices include the sigmoid function and the rectified linear unit (ReLU) function. The backpropagation algorithm has had a profound impact on the field of neural networks and machine learning as a whole. It enables the training of deep neural networks with multiple layers, which are capable of learning complex patterns and representations from large amounts of data. Backpropagation has been applied successfully in various domains, including image recognition, natural language processing, and reinforcement learning. In conclusion, the backpropagation algorithm, introduced by Paul Werbos in 1974, is a fundamental technique for training neural networks. It utilizes the concept of gradient descent to adjust the weights of the network based on the error between predicted outputs and desired outputs. By propagating the error backward through the network and iteratively updating the weights, the algorithm enables the network to learn and improve its performance over time. The backpropagation algorithm has been instrumental in advancing the field of machine learning, and has paved the way for many subsequent developments in artificial neural networks.